Thank you for joining the webinar. We'll wait 5 minutes for guests to sign on before we begin. Thank you for joining the webinar. We will begin our presentation shortly. We're just going to wait 5 minutes for guests to sign on before we begin. Thank you for joining the webinar. We'll wait just a few more moments for guests to sign on before we begin. We will start our presentation shortly. Thank you for joining the webinar. Good morning, everyone. Today's multifamily envelope modeling webinar is brought to you by Los Angeles County and Build It Green. Build It Green is a member-supported nonprofit organization working to expand the market for green homes in California. I am Diana DeKeek. I will be your moderator today. Before we begin, we'll go over a few housekeeping items. All attendees have been placed on mute. This webinar will be recorded. If you have a question you would like to ask, please type it in the chat box, and we will answer your questions during the presentation. If you're having trouble seeing or hearing the webinar, please let us know. If you're experiencing an echo and are using audio through your computer, you may want to try calling in again using a landline telephone. Our webinar presentation today will outline how to stay up to date with current modeling building envelopes and design strategies for combined high-rise and low-rise multifamily buildings. This webinar will provide raters and energy consultants with knowledge on the basics of multifamily residential building modeling using Energy Pro 5. We will review and identify modeling best practices as it relates to new and existing multifamily homes, and we will illustrate how to troubleshoot Energy Pro calculations. Our speaker today is Sean Furtado. Sean has been an AutoCAD designer for commercial engineers, architects, and design-build construction companies in California. With experience in energy modeling and energy compliance, he has been involved in helping make homes more energy efficient. Recently, he joined the Build It Green quality assurance team to ensure that models are coherent and reflect correct savings. Let's all welcome Sean.
Hello, thank you, Diana. How's everyone doing today? Hope well. So once again, I'm Sean Furtado. I'm a quality assurance project manager here at Build It Green. I am CEPE residential, Green Point rated existing multifamily, and BPI multifamily building analyst. My experience with multifamily buildings mostly has been living in them. I haven't really had a whole lot of experience with projects on multifamily buildings other than reviewing applications and looking over people's compliances for multifamily buildings. And I've also, while living in multifamily buildings, seen some small retrofits, mostly with boilers, nothing really with the envelopes. This webinar today is basically on multifamily buildings envelope and the assemblies for these envelopes. And so let's jump right in. Let's go to the first slide here. Before we get started, I'm going to just give a quick check on the chat box here. Can folks just chime in to see? I just want to see what your what you do as a profession. So if you're a rater, if you're an engineer or an architect, go ahead and type that in the chat box just so I know it works. And I'll check back in about a minute to see who we have in the audience. Okay, I'm not seeing anything from anybody typed in the chat box, so I'm going to assume you all are raters then, or Green Point rated, or HERS compliance rater of some type. Oh, there we go. Starting to see some responses come in. Very nice. Okay, we have an urban architect, we have raters, modelers, we have CEPEs, and let's see, we have designers, architects, let's see, HERS raters, Title 24 compliance modelers, and let's see, chief building scientists, and let's see. So we got a good group of green builders and designers and engineers and raters in this discussion, which is great. So this discussion will help many of you in your day-to-day building model analyses. So just a quick introduction of Energy Pro. So it's how I see Energy Pro. It's a really simple to use energy modeling tool. The way I like it because it's really easy to navigate. You don't really need a technical degree in order to perform an Energy Pro model or build an Energy Pro model. You just have to have a really good understanding of how Windows works and how Windows tree works, really. And many people know how to use Windows and Windows trees. You know, like you have a main file and you have a bunch of subfolders, and Energy Pro works the same way. So I really like that functionality of Energy Pro, and it's really nice because I don't have to build a 2D or a three-dimensional model, which can take, you know, somewhere between 3 to 4 hours, depending on if I'm using Riseand or if I'm using AutoCAD to build a model. So the Energy Pro makes it really simple, easy, quick, and saves me a lot of time as far as energy modeling, and I like that approach. And all you really need to know is have a general understanding of how buildings work as a system. So many of you are professionals in the industry who have experience with buildings and understand how they all work, how buildings work as a system. So I don't really need to go in detail about that. And the more information you get from an assessor, or if you're the assessor, the more information you get, the easier your models, easier it is to build your models. And also, last note is these slides for this presentation it's kind of meant for post-reading as well. So a lot of the slides make it be a little wordy or contain a little more information than needed. And there's also some links to some of the supporting documents that you'll see in these slides. Okay, so building envelopes and construction assemblies. So the building assemblies and envelopes have a pretty much a good relationship with the building envelope, with the HVAC and the domestic hot water system, but mostly the HVAC systems. So there's a really integral relationship that needs to be understood when it comes to the building envelope, because the HVAC systems need to keep up with how the building envelope performs. So we're going to be looking at low-rise and high-rise buildings as kind of together, not like combined, like, or we're going to combine low-rise and high-rise. We're going to be kind of grouping them in the same kind of group of buildings. So the main difference between low-rise and high-rise is they fall under different energy compliance metrics. So low-rise falls under the residential energy code, and the high-rise buildings, which is 4 stories and above, four levels and above, they fall under the non-residential energy code. So building envelope, this is all insulation, all the insulations, radiant barriers and cool roofs, attic venting, windows and any type of glazing or fenestration, shading, and infiltration and exfiltration. So those are the main components of the building envelope we're going to be discussing today. Okay, so Energy Pro follows the 2008 residential and 2008 non-residential ACM manual. So this ACM manual is an alternative calculation manual that pretty much dictates how energy compliance software it runs calculations in California. So the CEC mandated that any compliance software that gets accepted in California to use for compliance has to follow this ACM manual. And the ACM manual is full of calculations, formulas, and assumptions. And these are all of the metrics that are embedded in Energy Pro in its behind-the-scene calculations and simulation analysis. And as you can see, I left 2 links for both of these manuals here. So after the presentation this morning, you'll get the link for this slide deck, and you can actually find the links to these manuals if you don't already have them. But they're good references to have, because if you want to know how Energy Pro is calculating any of the metrics, this is a place to find it, is the ACM manuals. Okay, so some best practices for modeling, just some advice that helps me work more consistently, and it's also some advice I give to some colleagues and has helped them. So you want to familiarize yourself with the Energy Code, Title 24 Chapter or Part 6. Familiarize yourself with plan drawing and data collection forms. So you should understand how to look at plans or drawings and how to read data collection forms. So they vary from different businesses. So just have a good relationship with the person who gives you the data collection form, or if you're the one collecting the data, make sure you understand how to fill out the forms, so that way when you get back to the office you can read your forms and not get confused by your own data collection. Having a knowledgeable person on staff who can consult you on building construction, design specifics, any code issues, construction assemblies that aren't really known to an energy modeler is important. It's good to have someone who you can talk to, because a lot of the energy modelers may or may not have a lot of field experience, and if they get an assessment and they don't know how a building is put together or what something means, and if there's someone they can talk to who can clarify what a building assembly is or what a picture looks like, so they can best represent that in a model, that's always good to have. Let's see. And some Energy Pro examples. So if you have Energy Pro on your computer or on your hard drive, there is a folder in the documents, Energy Pro documents, that have some examples of buildings. So you can see how certain buildings are put together, the assemblies and the HVAC systems, and as well as the plant systems, or the domestic hot water systems. And it's always a good idea to not reuse your old energy profiles as templates. I've seen that the file duplication cause some errors and file corruptions, and past information always gets overlooked, and it causes the certain loads for, depending on if it's in a fan or heating or cooling or windows. I've seen it give calculation errors and cause buildings to not comply. So if you start from scratch, new file, it's always better, and to just give yourself time to build out a full model. Okay. So we spoke on in the previous slide about plan drawing and being able to read plan drawing. So there are two approaches to sketches, or getting data about our building assemblies or our envelopes. So generally, if you're dealing with an existing building, you're going to get a takeoff sketch, and they're pretty much visual confirmations of the site, just a quick layout, dimensions of the building, the elevation. It's just a real rough sketch. Doesn't have to be perfect. The takeoff artist should have some really good plan communication skills. So like I said, it doesn't need to be drawn perfectly, but it should represent the shape of the building, and there should be call-outs that are easy to read. So you only want to draw things that are relative to the building assessment. So if you're an assessor, or you're talking to your assessor about what information you need to put the model together, just the information that is needed in order to plan out your upgrades, or to get a good idea of what we're going to be modeling for the energy upgrade. So you don't need to draw things like separate buildings that have nothing to do with what you're going to be modeling. So just only stick to what's important to your information and what you're going to be giving as far as an upgrade to your clients or your building owners. So you're going to need 11 by 17 paper if you're doing takeoff drawings. And if you're doing new construction, you're probably going to be doing plan referencing. And with some existing buildings, you may get plan sets, but they may not reflect any kind of remodels or additions that might have occurred throughout the years. So it's always good to maybe just start with that and then follow up with a site visit if you do get a plan set for an existing building. But for new buildings, you're most likely going to get a plan set, and those are pretty easy to read and have architecture nomenclature. So again, the modeler should understand how to read these drawings and the call-outs for different assemblies. And also, sometimes I use Google Earth if I get called into a project pretty late and they don't have anything like as far as plans. I'll use Google Earth to get a floor plan, and then use the street view to get a good understanding of what each elevation looks like. And Google Earth is nice because I have a little scale metric on the bottom right, and you can use that to kind of scale out the drawing and just give a good rough drawing. It doesn't need to be perfect, like I said, but just to kind of give you a good basis, and then again follow up with a site visit when the time comes. But if you get called on a project late, Google Earth is great to use. Okay, so takeoff sketches on the left, you can see this is actually a really good takeoff sketch, but typically this won't have, takeoff sketches won't really need interior partitions or any of the appliances, but a fine level takeoff will have almost everything noted, and wet rooms and dimensions. But with your multifamily buildings, it will take you a very long time to draw the building, so you can most likely leave this information out. You can probably keep information about the stairs and the windows, but interior walls and the toilets and the sinks and the stove countertops, where those located, and each room dimension is not necessary. What the takeoff sketch really needs to have is the exterior wall dimensions and window locations and dimensions. Plan reference drawing will pretty much be a CAD or a drafted, computer-aided drafting, or can be a hand-drawn. Many architects still do hand drawing. Plan sets, and the plan sets may or may not come with dimensions, but they will give you scales to identify dimensions, so they're pretty much easier to use. But those are the biggest difference between a takeoff sketch and a plan reference is the amount of detail and what it's used for. Okay, so what are the important things you need to know? Your climate zone. So is your climate zone in a heating dominant area, cooling dominant areas, or moderate temperatures, snow? Is it dry or is it humid? So Energy Pro takes these things into consideration when it's doing its calculations. And so when you're thinking about your building and you're modeling your building, you really need to understand what area you're in as far as climate zone and how that affects the building. The type of assessment data you're going to be collecting and are receiving from your assessor is pretty much an ASHRAE Level 2 assessment, and that is built off an ASHRAE Level 1 assessment. ASHRAE Level 1 is just a really general high-level overview of the building. The ASHRAE Level 2 gets more into it's more of a survey, gets more into the systems and operations. It breaks down different end usage, and it identifies measures or what's wrong with the building shell or systems, HVAC systems or domestic hot water systems. But you're going to identify what those deficiencies are and what measures can be identified to improve those, and also spotlight any operational discrepancies, what can help the building maintenance operate the building more consistently, and outlining priorities for resources, next steps, and identifying energy efficiency measures, and also data collection analysis. So ASHRAE Level 3 is a little more detailed assessment, and it goes into data logging, which most haven't gone into at this level of our industry, but I hope that's coming really soon. So LowRise envelope characteristics. So typically they're at three floors or 3 floor levels maximum. So the typical type you see are 3 floors built on top of a garage floor level, or just 3 floor levels built on a slab, just like the one on the right and the bottom left. And on the very bottom right, we have different configurations of multifamily buildings, of low-rise multifamily buildings. So you have your attached row house, your townhouses, your townhouses with auto courts, and your typical apartments, whether they be garden style or just like the ones in these pictures. So I've pretty much lived in low-rise residential most of my life. I haven't had the experience of living in a high-rise residential building. So the characteristics of these for low-rise building envelopes, so they have a high shell to volume ratio, so that's the exterior wall. So there's pretty much more wall than volume, internal volume. There's a low window to wall ratio. A lot of these buildings have individualized HVAC and central domestic hot water systems. And it looks like a house, pretty much acts like a house, and there's very familiar equipment. So if you live in the residential single-family, detached single-family, or attached single-family world, then low-rise multifamily buildings are going to be pretty familiar, and the equipment you run into are going to be pretty familiar. These buildings have lots of meters, exterior surfaces, lots of equipment and appliances inside these residences, and these buildings also require a little more maintenance than your typical single-family dwelling. So our high-rise envelope characteristics, so you can see they're typically a little more, they're more than 3 stories, at least 4 stories. And as you can see, the top one is kind of a really kind of a minimized high-rise construction. And on the right and the very bottom are large-scale high-rise construction. On the right is pretty much what I typically see in the Oakland area and in the San Francisco area, and as well as Los Angeles as far as high-rise construction. And these high-rise characteristics for the envelope, they're mostly single buildings inside these. These buildings are single. They're not really, you don't see like garden-style high-rises. They're just one huge building. There's a low shell-to-volume ratio. There is a high window-to-wall ratio in these buildings. These buildings also have individualized HVAC systems. And I've seen these buildings have a cross between the domestic water being individualized and central. And most of the time these buildings have more elderly tenants, like they're mostly retirement homes. And these buildings also have dedicated superintendents who live in the building. And envelope envelope has less of an impact on the operation, but we're still going to get into it. They're typically master metered and have simple geometry, and usually has one set of drawings and a knowledgeable building operator on site. Okay, so I'm going to give a real quick pause and check in to see if there are any questions. So if you have any questions, go ahead and type that in. I'm going to go ahead and look at our questions to see if we have any. So yes, this course is for beginners. The question is this course for beginners? I'm sorry I didn't clarify in the beginning. So this PowerPoint presentation is for beginners. It's for experienced users, and we'll touch on a little bit of some advanced level analysis in the end, but not really going into details as far as system sizing and actually getting into actual specifics of energy efficiency measures. But we're just going to give a high general overview of energy modeling, what information you need, how to put together a model, and how to run an analysis for the assembly. So if you're familiar with Manual J, the ACA Manual J, this is kind of like the approach we're going to go with this webinar, is kind of outline what information you need to get a good load for your systems, or understand the load of the building for the systems. So shell to volume ratio, that's just the ratio of exterior walls to the volume of the building, or the actual units, if that makes sense. And does Energy Pro produce ASHRAE Level 2 and Level 2 compliance modules? No, it doesn't. So the ASHRAE Level 2 and Level 1 analysis is really just as a professional tool to use to help kind of give you consistency for your models. And it's kind of, that there aren't really, as you start getting into high-rise buildings, there aren't really standards in place for assessing. So we've kind of borrowed the ASHRAE Level 2 from the ASHRAE commercial manuals to kind of give us an outline of how to best do an assessment for a high-rise building, because they fall under the commercial sector in a lot of cases. So, but again, it's just to help give you professional guidance as to what information you need for your building model. Okay, it looks like that wraps the question, so I'm going to go ahead and move on. Okay. So the Energy Pro building tree. So if you haven't seen Energy Pro, you're going to, when you start a new file, you're going to get 3 screens or 3 panels that'll pop up, and the main one is the building tree, and you're going to build your energy model in this building tree. So if you aren't familiar with it or don't know how to build a building tree, we have some tutorial videos on YouTube that go into how to build these trees and how to actually pick the right assemblies. But this is what this webinar will go into those details as well. But this is what the building tree looks like. So in this example, we have a low-rise building with 3 floor levels. And so you'll see the building panel, and under that building panel, you'll see a bunch of different options that you can click. So the first thing that's already set is the building, which is in the left side here. The libraries, which contains all the information about our assemblies, which we will use to model our building tree. And that's what we're going to primarily be looking at in this presentation, is the assemblies as they relate to the walls and the windows, as well as the roofs and the floor assemblies. The assemblies all fall onto the wall, floors, and ceilings. And the fenestrations are all the windows, including the skylights. We are not going to go into overhangs and side fence, just for the sake of time. So we'll get into that when we get to the windows section. But this is the section of the Energy Pro building tree we're going to be working in. Okay, so the building envelope zone. So after you have built out your domestic hot water and your space heating equipment, you're going to define what zones the HVAC system and the domestic hot water system are serving. So with my building example, I only have 1 domestic hot water system and 1 HVAC system. They're all actually individualized systems that serve every dwelling unit. If you saw our previous webinar on HVAC systems, you'll understand that. But we're going to be looking at what these systems, these individualized space heaters, are serving. So they all serve. The individualized space heaters are in each floor level, and we're going to model out each floor level in Energy Pro. So I'm going to go back real fast. So as you can see in this example on the left, we have 3 floor levels. So that's what you want to build out in Energy Pro, is have a different zone represent each floor level. And there's 2 ways of doing this. You could build out, let's say if you have a high-rise, and like on the right-hand side, I have a 5-floor residential building. You can use the building, the multiplier, which is in the general tab. Once you click on the zone, there's going to be a general tab that shows up, and in information you're going to need to put in, and then the very end is going to ask you if it's a multiplier, and that just lets you know how many times you want to multiply that floor level. So if in this example, I have a second to 4th floor, I'm going to be using a multiplier of 3 to represent the 2nd, 3rd, and 4th floor. If you have a roof and a floor, you have to model out the floor levels that represent the roof and the floor assemblies. So you're not going to be multiplying any roof or floor assemblies. You're just going to have to model that out separately. Or you can do a level-by-level analysis. And the pros and cons with the multipliers is it saves you time in having to model out multiple similar zones. But the con is if you have, let's say the 2nd and 4th floor had different bedroom numbers, you won't be able to capture that consistently, because Energy Pro is going to multiply what you say is the number of bedrooms for this specific floor and multiply that by 3. So if you let's say for example you had 20 units in the 2nd, 20 units in the 3rd, and 20 units in the 4th, it'll be a total of 60 units that gets multiplied. But let's just say in reality there's really 80 units total. Then the multiplier is not going to capture that. You're going to have to go with modeling out each floor level and designating the correct amount of room numbers for that floor level. And we'll go into that in the next slide. Okay, so that's the zone level, and that's AKA the floor level, just to give yourself a reference. This is kind of what we use to see what floor levels you're representing. So after we built out our zones, we're going to build out our rooms. And these rooms are going to be represented in blocks. They're not going to be each and every dwelling unit. You can do it a unit by unit analysis, but if you have, hypothetically speaking, 139 units, this is going to take you a very long time to build out, and the person who's going to be reviewing the model is probably going to have, it's going to feel like pulling teeth looking reviewing that kind of a level of analysis. And not to say that it's wrong, it's just very time consuming, and an Energy Pro will still calculate savings in the same general range if you block all the multifamily units into one level. So what we typically like to see is all the rooms for that floor level grouped into one block. And you're going to give us the total area, or the analysis is going to give you the total area of that floor level, and what all the rooms added up equal. So other information you're going to need is the average ceiling height for that floor level, or for all the rooms. The year built or the vintage of the building for each of these rooms, you're going to input the year built. They're typically not going to be different, so they should all have the same year built. You're going to be asked in Energy Pro what type of assemblies or the type of room. It's either going to be existing, new, altered, or removed. Existing is if you're dealing with an existing building and nothing's going to, you're only going to be doing some one-for-one retrofits. New is a new construction if you're building a brand new building or a brand new assembly or an addition that's put in. And altered and removed is pretty much for if you're doing Title 24 or compliance. So if you're doing some remodels or remodeling, these two types will be used to represent if a wall was altered and or removed, or any kind of configuration changes. That's for the altered and removed. There's going to be an occupant tab when you click on the room, and that's where we're going to put in the number of kitchens and number of bedrooms. And so the number of bedrooms for each of the rooms should total up to what you put in the very top of the building. So when you start your building in Energy Pro, it will ask you what the number of dwelling units are for the building. So if you put 60 units as the total number of units for the apartment, then each of the rooms should have a total room number that adds up to 60 for each of the four levels. So again, for multifamily buildings, each room should represent that floor level or that zone, and I think the common area should be included in the buildings unless the common area is a completely separate building and is on its own meter. Okay, so other relevant information that's in the tab icons for the rooms. So you're going to see an exhaust fan tab at the very end of the room. There are a bunch of tabs in Energy Pro that we aren't going to be concerned with, but what we're going to be looking at for the room icon is the general and the exhaust fan tab. So the exhaust fan tab is where we're going to be used to model all of the exhaust fans for the building or for that floor level. So I'm going to go back to this last slide here. So this room icon, which I labeled L1 rooms, will have a tab that will say exhaust fans, and it will ask us what is the output of CFM and the output horsepower. So you should kind of get, if you're doing your sampling, you can say, okay, I checked out all the 10% of the rooms on this floor, and they came up to maybe, let's say, 30 CFM per dwelling unit, and they all had 1/8 of a horsepower motor. You're going to add up all the CFMs and horsepower, and you're going to put that into the exhaust fan tab. Sorry, I don't have a real clear slide on that tab. I couldn't fit it into the slide without making you all squint. So if you have Energy Pro, or if you haven't looked at Energy Pro, you can also always download it and run it without any modules, and you can see where this room, the room icon and the exhaust fan tab is. But if you are familiar with Energy Pro, you should know where this fan tab is and what I'm talking about as far as the exhaust fans and horsepower and CFM. So the motor drive efficiency, so there, I think the default is 97%, and unless you pull apart the exhaust fan, you're not going to really know what the motor efficiency is. So I just would default to the 97%. Okay, so I'm going to go ahead and check in on questions to see how everyone's doing. And again, you can always put in questions as I'm going on. So I'm explaining, going on in this presentation. So you want to put I have one question is, I always get an error with more than 6 bedrooms in a home. Is this a particular reason? So the error messages, you can ignore that unless it stops. Like, there are 2 types of error messages in Energy Pro, one that actually stops you from running calculations, and one that just kind of like, hey, you know, you have more bedrooms than what's typically found in a residential building. Are you sure this is correct? But it'll still run the calculations. It's just kind of like a warning. But there are calculations that'll stop you, like if you set the occupancy type to multifamily and you're actually doing a high-rise calculation, it will stop you and say, hey, no, I can't do this calculation because you have the occupancy set to a multifamily, not a high-rise. And you have to go in and change that in order to run the calculations. Let's see. I always have exhaust fan, non-res only. I'm not too clear on that question. I haven't ran, the exhaust fan calculations in the non-residential module to see what the loads come out to, but it would be my assumption that it does include that in the calculations. But there is a residential tab in Energy Pro that is for mechanical ventilation. So there's 2 different tabs: residential mechanical ventilation and actual exhaust fans. But you can email me at the end, and we can maybe go into how we can work on non-res and exhaust fans. And yes, you want the total CFM, so add up all the CFMs and all the and I think the average, you want to average the horsepower, but you want the total CFM. Can you explain modeling rooms, dwelling units, blocks again? Sure. So I'm going to go back to my slide here. So when you're in the zone level in Energy Pro, you can right-click and it'll say Add Room. I don't have Energy Pro on this laptop. I have it on my computer, my desktop, so unfortunately I won't be able to pull it up to show you how to right-click and add a room, but it's really straightforward. You right-click, it'll ask you Add Room, and you add the room, and this icon will pop up with a kind of a default name, and you'll go ahead and name your room accordingly. And this room is representative of that floor level. It's a block load. It's not a unit-by-unit analysis. You can do a unit-by-unit analysis if you have, let's say, a really small low-rise residential building, like let's say only 16 units. That might not be difficult to model out, but if you have a residential building or a high-rise residential building with maybe over 50 units, it gets pretty messy and it gets really hard to review as well. So it's easier to keep it as a block load, and the savings is still relatively close. It isn't as detailed as a unit by unit, but it still gives you good saving analysis. So why include the common area? So the 2 reasons: because I like to see the whole building in the energy model, and this common area has a play on what the residential building or portions of the building it's experiencing. Then I feel like you should model it. But if it's separate, totally far, has no relationship with the building, and then it doesn't need to be modeled. But that's just my approach to it. And I just think that the building should be best representative of what you find. And as far as Energy Upgrade California or Greenpoint rated, it's most likely you're not going to be doing anything to these common areas. So, I mean, I guess I think it's a good idea to include it, just for the sake of actually getting a good load analysis. And again, if this common area is separate from the main building where all the residents are living, then don't model it. Okay, there are many things that don't run in LRR, but do low-rise residentials, but do in residential. So that's the thing. When you're doing a low-rise residential calculation and high-rise residential calculation, you have to understand that you're using two different energy code compliance metrics. So one for residential and one for non-residential. And as far as the components go, all of the assemblies are going to stay the same. The systems are pretty widely different, and as far as calculations as well. So we're only going to be looking at the building envelope and what the calculations can do for the building envelope. So would you perform exhaust fan calculations on a low-rise rehab when sampling is involved? Yes, I would. I like to. I'm a real detailed person, so I like to get as much information about a building as possible. And if I can get information on the exhaust fans, I will include that. And there's ways of showing with the two-model approach how to get savings from the fans. So you will get a baseline fan or test-in fan when you model it, and you can do it another model, two-model approach, and compare it and see what my fan energy use is for the improved building. Okay, so that looks like that wraps up the questions. Go back to the presentation. Okay, so our assemblies. So let me go back once again to this picture here. So we're going to be working in the assemblies now in Energy Pro. So we've already built out our rooms. Now we're going to build out the assemblies for each room or for each floor level. That makes sense. So the assemblies are all, if you're familiar with RightSoft or any of the load calculation tools, you know that there are a library of building assemblies already pre-populated into the simulation. Energy Pro is the same, but it doesn't use the heat loss calculations that were typically taught in our classes. This Energy Pro uses what's called the Joint Appendix JA4, the U factor, C factor, and thermal mass data. And here's the link for it here in the slide. But if you go to it, it will give you the list of everything that Energy Pro has as far as assumptions when it comes to the assemblies for all the walls, all the floors, all the ceilings, the roofs, and the windows. So, and there are many different types of assemblies. But again, so what you're modeling with our assemblies is just the exterior thermal boundaries. So we're not modeling any interior partitions. We're just modeling all of the exterior walls, all the exterior floors, and exterior ceilings. So the front door should be modeled just for the front of the building. So the first floor level should only have the front door. They're not going to be modeling in front doors for all of the residential buildings, just the main entrance of the building, and that's going to be representing the front, our front exterior wall. So in the right side, you can see a picture. I have labeled my assemblies per orientation. So we have 4 walls for each orientation, and the front representing this front will be representing of my front door of the building, not for each of the dwelling units. And I'll only have that for this level. And let's see, all exterior walls, raised floors, slab on grade, raised concrete, and roofs should, with or without attic, should be accounted for in model. Again, partition walls, floors, and ceilings, don't include those. And as far as windows, this is kind of like the pain point for, I think, most energy modelers, because I mean, you have to model. It's best practice to individually model out every window, and getting this information from an assessors. That's probably the most lengthiest part of the analysis. Okay, they have so many windows. You know, you have to sit there and model out every single one, or can I aggregate them all into one sum? This can be done in a sum, but you're not going to be able to capture all of the shading features. Mostly the side fins. You can, if the building has overhangs, you might be able to capture that by grouping all the windows into one sum, but you won't be able to capture any side fins. So if each of the dwelling units have partitions that pop out and cover the windows, you know, to a degree where there's, you know, you can call it a side fin and it's giving it shading. You won't be able to capture that if you add up all your windows. But if you have individual windows, you can capture the shading capabilities of each of those windows. And that can also help improve your cooling loads if you're in a heating dominated climate zone. Skylights are modeled in the roof. So if once you build out your assemblies and you get to the roof, you right-click and you add in the skylight from the roof. You don't add it into the walls. And just speaking on just assembly defaults, you should use them if you aren't able to get information on the type of construction. But it's always best practice to get that data and to do a full analysis and try to find out what the assembly is really about and what the R values or insulation levels are really for the assemblies, and use the defaults only if this information can't be found. Or again, if you're called in late on a project and they've already started it, and the project's gutted, and you don't know what was there, the defaults are a good fallback, and they pretty much represent building codes from that vintage. So I think it's a good representation if the information wasn't explained in some shape or fashion. So getting into the walls. So the walls are pretty much the best defense against heat loss and heat gain. And so they're pretty difficult to insulate if the building's already built. If it's a brand new building, it's always a good idea you have to, it's code, to insulate all the walls. But for existing buildings, it's really hard. So blown-in cellulose and fiberglass and some spray foams are good options for these retrofit situations. So when you click in the Energy Pro walls, you'll be asked to put in the existing assembly. And when you click on this default, where this says default wall 1992 to present, you'll get the library for the list of the wall assemblies. And you can see here I have in blue highlighted the assembly that was chosen here. But if let's say this wasn't the assembly that was for my project, you can look in the list in the library here to see what best represents the wall assembly you have, or you can go to this little green arrow and import the wall assembly from the list that the commission has put together, and you can use that. But the only caveat to adding when you import is you have to use a little yellow plus button here, which adds a new assembly. You're going to have to rename that and then import that renamed assembly, because this add just copies whatever you click, what you have clicked. So if I click this yellow plus button, it will give me a copy default wall 1992 to present. I'm going to rename that to my wall. Let's say it's an 8-inch CMU wall, which I already have here, but I'm going to rename that and import that from the list that the commission has put together as far as assemblies. And if a building has complex geometric designs, you're going to sum the orientations, sum all of that orientation. So on this next slide, this is what I'm basically saying. If you have a building that has jogs and different shapes, you want that orientation to add the orientation. So the oranges get added, all the blues get added for that orientation, all the greens get added for that orientation, and the reds get added for that orientation. And we have two separate 45-degree orientations on the bottom here of the screen that will be modeled into our model. So in our building tree, we're going to have, in this example, 6 walls, one for the front, one for the back, the left side, and the right side, and these angled edges here. And if you have, let's say you have like a real, or like say a rounded, quote unquote, not really rounded building, you're going to look at it in 45-degree increments, because the analysis is so much. I mean, you can go into each and every elevation, but the analysis won't give you that big of a savings difference when you do a 45-degree breakdown of each of the walls. So just make it simple for yourself and make it simpler for the person reviewing your drawings, and just keep it, very, very high level. But if you want to go into details, you can do that as well, but it's just going to be more time consuming. So just remember that if you want to go into more detail with your analysis, it's just going to take more time, and make sure you have enough time to build out your models and spot check it. But this is a good approach that a lot of people are using for complex shapes just like this. So windows and doors. Again, this is the biggest component. Windows are actually the biggest component for the cooling loads, and they are the most time-consuming feature to add in our energy models. And again, combining the windows is typically practiced, but isn't allowed for shading, which I said in the prior slide. It's a good idea to use the defaults if you don't know what. I mean, a lot of times you're going to have to with the existing windows, because there weren't any standards in place when Windows were developed until recent years. The NFRC has been certifying Windows and window performance. So with older buildings, you're going to have to default to the vintage, and Energy Pro has the assemblies already built into the tree. So when you click in the existing fenestration, you'll get a list of some of the defaults for single metal, non-metal, double metal, and non-metal, and if it has a tent or not. And skylights are very similar, but you're going to model that into the roof, not on the walls. You just right-click, add skylight, and the skylight will be very similar to what we see in the screen here. Sorry, I don't have a picture of the skylight. And there's typically only one front door. That's what we really want to see, is the front door for the main building, and not every single dwelling unit. And if you do encounter a building and it does look like it has new windows, try to find that NFRC sticker. If you don't know what the NFRC sticker looks like, it's here on the very bottom left. It should have like this arced window here with the sun's peeking through, and it'll give you the U factor and the solar heat gain coefficients for that window. Some of them may have more information, like with the visible transmittance and the infiltration, but what we really want to see is the U factor and the solar heat gain coefficients for this rated window. But if you don't see that sticker, you have to go with the defaults. And again, they're a big component to the cooling load. So if you're in a heating dominated climate zone, you might really want to look at the windows and how to lower or improve the performance of the windows. So next we're going to get into the floor assemblies. Typically, you're going to see either raised slabs or raised concretes, or if it's a low-rise residential, it may be on a crawl space or on slab. But most high-rises have like a huge underground basement or some type of raised slab. They're not really on small crawl spaces. They're on huge pillars and on slabs, raised slab concrete. Energy Pro also has pre-populated assemblies, and if you want to import, again, you can hit the import button and you can see the library, and you can pull in the assembly, whether it be a raised crawl space, no crawl space, or if it's a raised concrete for a parking garage of some sort. So that pretty much wraps up the floor assemblies. They're pretty straightforward, and you're only going to be modeling that for the bottom level, the first floor level. We're not modeling, again, we're not modeling any floor partitions, only exterior, anything related to exterior partitions. I'm sorry, exterior walls or floors or ceilings. So getting into the ceilings, very similar to the walls, very similar to the floors. You just right-click and add a roof into our rooms. And this should only be for the top floor only, not unless you have different floor levels that have different areas with a roof, then you will model out that. But if it's a consistent high-rise, for example, you're going to just model the roof at the top level only. And again, use the pre-populated Energy Pro assembly. And if you don't see your assembly, you can always import it. And just to give a quick example here, you'll see in Energy Pro, just like with the floor, you'll see these pictures that gets popped in. And these are the same pictures that you see in the Energy Commission's JA4. The assembly kind of, let's see, this very top here, the joint appendix. So all the pictures from the joint appendix are similar to what you see here and here for the roof and in the floor. So it's taking that straight from the code. So some additional information about the roof that's pretty important, especially if you're dealing with a cool roof or radiant barrier. So there's the CRRC1, or the Cool Roof Rating Council Certified Roof Rating. You want to check that, and you want to put in the solar reflectance and the thermal admittance, and it should fall in your jurisdiction's energy code. So there's going to be compliance standards for if it's a low slope or steep sloped roof, and what those compliance or those metrics are, or requirements are for those types. If you have a radiant barrier, you're going to have a drop down and select the different types. There's continuous, and there's continuous with skip sheathing, I believe. And if you are modeling this per Title 24, it will, that's because Title 24 asks that when you install a radiant barrier that you also add an airspace and do the 1 and 150 attic vent and have a 30% high roof. So if you click all these three, or if you're doing these things in addition to the radiant barrier, or if you find that you have a building with these conditions, make sure you note that in your assessment, and so that the person who's doing the model can accurately reflect if the building has a radiant barrier and its energy savings. The added interior insulation and exterior insulation, these features are in all of the assemblies, the floor, the walls as well. And this is if you're adding any interior insulation and framing to the prior assembly. And most typically, if you're dealing with an existing building, this isn't going to be needed at all. So what does Energy Pro use for calculating envelope loads? It uses for LowRise the 2008 Residential ACM Manual, which we went into in the beginning of the presentation, Section 3, and this shows detailed calculations for the assemblies. For high-rises, it uses the 2008 Non-Residential ACM Manual, Section 2.3 and Sections 4.33. And so I gave you guys links in the earlier slide to these documents. So once you get this, once you get the slides, you can get the link, or if you already have the link, you can go to these sections and see what those assemblies look like, and pretty much you'll see these pictures from here and here, and the roof and the ceiling and the wall. Okay, so now let's jump into, actually let's look at the questions. Let's see if we have any more questions that came along. Okay, so PG&E EUC. Let's see. So does PG&E EUC California multifamily models individual units or partitions ever? No, and only in the single family program. There's a 2 to 4 unit program that is actually just using just the model from that resident. But for best practices and for our program for the Greenpoint rated, you want to not model out every single unit and just model out just that floor level as a block load, and partitions as well, as they don't really make that much. They won't make any difference in the energy calculations. In actual, I haven't really had the need to use interior partitions when I'm doing any energy compliance for Title 24, and I haven't had any plan checkers ask me to include that into the model simulation. So they only wanted to see exterior walls, not partitions. And let's see. Okay, I don't have any more questions after that. Okay. Okay, all right, and let's see. I can't do any calculations on this webinar right now, so unfortunately, just shoot me an email and we'll work out. I'll show you how to do. We can do a log me in one-on-one screen sharing, and I can show you how to do it when I get to my desktop, but I can't do it on this laptop right now to show you the calculations. So just shoot me an email after the webinar, and we can work through that exhaust fan calculation. Okay, so moving on. So getting into calculations. So we're going to get into this section here. So again, if you're familiar with Energy Pro, you're going to see a list of clicks or tabs or columns, rows, whatever you want to call it, with icons that relate to our building model. We already went to the building. We went through the building. We already went through the libraries, our assemblies. Now we're going to look at our calculations. So when you click on calculations, you're going to get this screen on the bottom, and you're going to get a list of different calculations. And these are the different modules that you will purchase from EnergySoft. And so the main two that we primarily deal with, and some of you deal with Res Cal certs. I'm not a HERS rater yet. That's next on my list, so we'll have the Res Cal certs on my tool belt within the year, and as well as Title 24 compliance. But mostly we're going to be dealing with, since we're building green, the Greenpoint rated, the res performance, and I didn't check the non-res performance, but the non-res performance for our high-rise buildings, our multifamily buildings. And you can see here on the top, I've noted that you can use the Greenpoint rated for both high-rise and low-rise residential calculations. And for low-rise, you can only use the res performance module, and for high-rise, you can only use the non-res performance module. Okay. So going back, actually, so when you click on the calculations, you can see a bunch of different tabs. The options tab here, we're going to click this radio button here, the run measures combined together. If you want, you can go into this level of detail, but it won't make any difference for your savings calculations or your compliance calculations. It's just more for reporting for your clients. So if you're doing any type of finance calculations, you can put that in. But we're going to be just making sure this run measures combined together is selected. And we're going to click the alternatives tab, which will bring us to this screen or this layout. And so the alternatives tab is where we will put in information on the improvements. So if we're doing a res performance or a Greenpoint rated project for an existing building, we're going to have our baseline building tree already modeled, and the alternatives is where we'll put in all our upgrades or all our improvements. Typically, we won't do building leakage because blower door is typically not practical in 50-unit residence. But if you have maybe like a six-unit residence and you have 6 blower doors, go ahead and knock yourself out with getting a building leakage reduction. But it's typically not feasible in many high-rise residential buildings. So again, this is a combined high-rise and low-rise, so we're pretty much looking at it from the same perspective as well. Can I do this in a high-rise? And no, you can't. So you typically can do the roof insulation, wall insulation, floor insulation, windows, and I didn't check that, but you can do window upgrades for high-rise and low-rise. So it's just some alternative design strategies. You want to choose an upgrade that's viable for the building. So something that will work for the building and not just do it for the sake of an upgrade. Wall insulation has the biggest savings potential that I've seen. Attic and floors have relatively minor energy savings potentials. I know Manual J shows me a huge load reductions, but with Energy Pro, it pretty much looks at insulation improvement as it relates to the HVAC systems. So unless you're changing the HVAC systems out, you're not going to see huge improvements like with the wall insulation. So the attic and the floor have relatively minor energy savings, somewhere between 5 to 7%. The wall insulation is around 20%, 15 to 20%. That's just what I've seen. Your buildings will vary. They're not all the same. As they say, all buildings aren't created equal. So make sure when you model these different improvements that you see where your building is, what the orientation is, and if you can actually do these upgrades for the building. Window films are great, low-cost option as opposed to actually installing Energy Star windows because of the high install cost. And so basically, window films would just be using the Energy Pro default for the window film, but you can still see savings somewhere between 5%. So that's a good low-cost option. Skylights are also included in the windows calculation. So if you have skylights in your model and you aren't going to change that out, you have to change that surface type to new, so that way it won't get calculated. Otherwise, Energy Pro will include that in the fenestration or the windows calculations. If a building has high infiltration, you should typically do any type of weather stripping. So if you go into a series of dwelling units and they're leaky from the windows having bad sashes or the doors not having any weather strippings or sweeps, it's a good idea to install them anyways, even though you don't get any Energy Pro savings. So there are a lot of low-hanging fruit things that should be done, that can be done, that Energy Pro won't capture, and especially with the infiltration and exfiltration. But the building or the actually occupants will be more gracious than anything if you cut down on the infiltration. So after you run your calculations, whether it be the Greenpoint rated or the res performance or non-residential performance, you're going to click on our reporting options, and our reporting options will give us our savings. And what we're going to be looking at is the Econ 2. So when you click on reports, it'll give you a list of different reports you can get and what you want from the report. So I clicked the residential performance and the non-residential performance. I didn't have that checked, but I want the Econ 2 from both of those. And sorry, this picture is so small. You're going to get when you're looking on top of Energy Pro, you'll see a little icon with the magnifying glass, the preview, and that'll give you a preview of the report. And since I want a preview of the Econ 2, this will give me a PDF preview of the Econ 2. And I'm sorry it's so small, but you can see all of the improvements. I have roof, wall, and window insulation, and this is a low-rise residential building. It's giving me 15% savings. Okay. Actually, I do have a close-up of that here. So the same example, I actually just changed one into a 4-story high-rise, and this one on the top is a 3-story low-rise. And you can see the roof, wall, and window. This building was on slabs, and this one on the bottom is on a raised concrete. So I don't have any floor improvements that I could have chosen. But I have seen with some of those raised concretes, the blown-in cellulose that gets blown in on the bottom and it's just sticking on the top. But anyway, so with this calculation, I ran roof insulation, wall insulation, and just the window films, and you can see I got some good savings potentials. And we're going to be looking at the TDV savings, the time-dependent valuation savings, for the building. So for the non-residential, you can see the same upgrades didn't have as big of an impact, but I still got good amount of savings from the wall insulation, and some from the window films too, given the cost. And these savings are just based on what I put in as far as my metrics on the calculations, the options tab here. Okay, so again, common calculations in Energy Pro. We have loads, which can give you the different loads for the zones or floor levels. Residential tile 24 performance, which many of you already know, which will give you a compliance margin based on the proposed and what you have modeled and what's actually code, and if you're actually beating that or not. Greenpoint Rated is a module that takes your building's vintage and compares it to a building from that vintage with improvements, and gives you a target index to meet. And your building at test in or test out will either meet or not meet. It should meet the Greenpoint or beat the Greenpoint Rated target index. The CalCerts module gives you a HERS score. I don't think this is approved for multifamily, but I think that's good practice to just enforce what the HERS score is, and maybe get people thinking, what a HERS score would look like for a multifamily building. The residential performance module, I didn't include the non-residential performance module, but they're both the same, also known as Energy Upgrade California. So these modules are typically used to model a baseline or your building street with the alternatives / the improvements. And you get a site or TDV savings, and you use that to get your rebate based on that percentage. Help and support, Energy Pro user manual, Energy Pro YouTube videos from Build It Green and Martin Dodd. Build It Green, we have our own YouTube channel with multifamily and single-family videos, tutorials. So they're really short, they're not long 1-hour videos. So they're really specifically related to the component level. So we have videos just specifically related to Windows, and one related to just specifically HVAC systems, and one related to just how to put together, getting information from a takeoff and putting together the building. And Martin Dodd has some videos from CBPCA that's up, and I think BK also has some videos on Energy Pro as well. Energy Pro support should be used if you have some software or technical questions regarding your software. So if you have typical modeling issues, they can assist you, but it's good practice to try to figure out, if possible, if it's a software issue or if it's just something that me as a industry professional should know. A lot of the stuff isn't really that intuitive to find as far as why calculations give you certain numbers, and we can help you with that via Greenpoint Rater, Ask an Expert, or if you're in Energy Upgrade California, you can email the Build It Green utility, and I'm open to any email questions, as well as if you have any calculation issues, why your building's not complying or you're not getting the savings you needed. So those are some help and support options. And so I checked one last time to see if there's any more questions before I wrap up this webinar. We're getting close to 12 o'clock here. I know you guys are hungry. Let's see. So I got a question for the alternatives tabs. What if I have two different types of windows? So what you would typically do if you have multiple types of windows, like, okay, let's say I have a slider in some situations and I have double hung windows in some situations. Double hung window has lower performance than the sliders. You're going to be using those solar heat gain coefficients and U factors from the lowest performing window, not the highest performing window, and they're not average. The reason why use the lowest performing rating is so that when someone actually goes on site to verify your building, they're going to be looking at what you used as far as your spec sheet and what's actually there. So if you have something modeled that isn't shown on the spec sheet or what isn't there, then there may be some conflicts. Okay. Well, not too many questions. Looks like so yes, this video will be recorded, is being recorded, and Diana will give some information as to how the webinar can be accessed, and as well as these slides in future emails or upcoming emails. So with that, it looks like I'm going to wrap it up and turn it back over to Diana. Thank you all very much for joining this webinar. Appreciate the time, and I really hope this webinar was able to give you some guidance and help support you in your energy modeling and give you some confidence in producing more of these models. Thank you very much.
Thank you, Sean, for this informative presentation. I hope that everybody enjoyed it. Thank you, everyone, for attending. If anyone does have any additional questions, you can contact Sean directly at his Build It Green email. And this webinar will be saved on the Build It Green website for future access. We will email you an updated link. And for those of you that are still interested in attending another multifamily related webinar, we have one scheduled next week on Wednesday, April 24th. And that's titled How the Multifamily Pilot Program Can Help You Build Your Business. I hope you can join us for that as well. Hope you all have a nice day. And if you have any additional questions, please feel free to contact me at ddekik@builditgreen.org. Thank you.